Alright, well this is day one of a new unit dealing with something called function composition and also later inverses. But today we'll focus on function composition. Basically, function composition is substituting a function into a function. Now, we're used to things that look like this. Say f of x equals 2x plus 3. If we were asked to evaluate f at 5, we would know that that would mean just take the 5 and plug it in for x. So that means that f at 5 would equal 2 times 5 plus 3. And of course that would be 10 plus 3, so that would equal 13. Alright, so that's how it works when there's a number at which we are supposed to evaluate. But what we're going to do now is instead of substituting in a number, we're going to substitute in another function. So it's going to be like, I feel like I should switch colors here for a second. So like instead of there being a 5 here, there'll be another function in here like function g. And we'll be expected to take this function g and substitute it in for x instead of the number. And I'm going to show you exactly how that will work. Alright, look at example number 1. We're supposed to find f at g. That means we're going to start with function f and we're going to substitute in function g, just like I substituted the 5 in a minute ago, but somehow I'm going to substitute in a whole function g. Well, both functions are listed over here. So let's start with the outer function, the first function, function f. If I'm going to substitute anything into function f, the first thing I would do is write down what function f is. So function f you see is x plus 4. So what I would do if I were you is I would write the function, but instead of putting an x, I would put a parentheses. Okay, so what I have written here in blue, this is function f. Only thing I changed was because I know I'm about to substitute something in here, I put a parentheses instead of an x. Now, the thing that's supposed to go in here is function g. Now, what is function g? Well, that is x plus 9. So that's why I'm going to take this x plus 9 and put it into function g. So the x plus 9 goes right here. So you see I've sort of color coordinated for you. So we have function f in blue and then function g in red on the inside. And that's what you see here. Function f is the blue and then here's function g being substituted in. Now the most common mistake a lot of students will make is they will keep the x from the original function f. So they'll wind up distributing that or something and have x squared plus 9x or something. We're not writing function g next to function f. We are substituting it in. So do not write down the x, the original x from function f. Put a parentheses instead so we have something to substitute into. After that, it's just a matter of simplifying. And for that, I'll switch to purple. But the look, basically, because there's nothing to distribute, there's nothing in front of the parentheses aren't really doing anything, so I could basically erase them, and you see that all I'm really doing is combining like terms. So this is going to wind up being x plus 13. That's it. That's all there really is to it. The examples can get more complicated, but that's the basic idea. Let's do it again. Alright, the original function is function g. So this time we're going to do function g on the outside, and then on the inside we're going to substitute function f. So let's start with function g because that's first. Function g is the function negative 5x minus 1. Again, see what I did? I just wrote the function down, but instead of putting an x, I put a parentheses instead. Now inside the parentheses goes function f. And so here's function f right here, and I'm going to substitute that in. Notice I don't have any x's here so far. Okay, this x is a parentheses now, and so I will substitute the 2x plus 7 in there. Now because I have this -5 here in the front, I'm going to have to do the distributive property. So I'm going to wind up going bam and bam. So this is going to be -10x minus 35. Okay, and then we still have this -1 sitting over here, so don't forget about that. Combining these like terms, that's going to leave the final answer of -10x minus 36. Okay, let's look at example 3. Now, if I were you, if you've just been watching me do these last two examples because you basically had no idea what to do, I would pause the video at this point and try to do each problem on your own, and then run the video again and see if you're getting the right answers. Alright, I'm going to pick up the pace a little bit as I hope that you're understanding. So function f will be on the outside, and then function g will be on the inside. There's how I will color coordinate. So first function f. Function f is 7x plus 6. Put parentheses instead of the x. No x so far. The only x is going to come from the function that I substitute in. Okay, so here comes function g. On the inside is my 6x plus 7. Okay, just like the last problem, I will do the distributive property now. So that's going to give me 42x plus 49. And see this plus 6? It's still there. Then just combine these like terms, and that's your final answer. So this will be 42x plus 55. That's it. Easy peasy, right? Let's keep going. Okay, this time function g is on the outside, and function f is on the inside. So let's start with function g. Function g says x plus 8. Just put parentheses instead of the x. Not next to, instead of. And now inside of here goes function f. So that's why I will put x minus 8 in there. Well, these parentheses are not really doing anything, so this is really just x minus 8 plus 8. These really wind up just canceling each other out. So that just leaves x. Okay, by the way, something that we're going to see in a future episode is that whenever this happens, notice how everything canceled out and you just got x? That means that these two functions are something called inverses. They just undo each other. But that will be the subject of the future lesson. Okay, f of g, or f at g. So function f is on the outside, and then function g will be on the inside. Okay, so function f, it says 2x, so I'm going to write 2 parentheses. And then function g goes in there, so that's going to be my 5x. I'll just wind up multiplying these, and that'll be my final answer. So that'll just become 10x. That's it. Let's look at example 6. On this one, function g is on the outside. Alright, and then function f is on the inside. So let's start with function g. Function g says 3 minus x, so I'm going to write 3 minus parentheses. Inside the parentheses goes function f, so that's why I'm going to put 5x plus 4 in there. Okay, again, it's important that we use these parentheses because hopefully that will remind you that you need to distribute this minus sign. This is going to work just like if this were a -1. So we have to take this -1 and distribute. Okay, so -1 times 5, that's going to give me -5x. -1 times +4, of course, is -4. Alright, a lot of kids just erase the parentheses and leave this at positive, but that would be wrong. And now the 3 in front just comes on down. We're almost done, but we still have these like terms. The 3 and the -4 together make -1. So the final answer is going to be -5x minus 1. Okay, that was example 6. What about example 7? Okay, in example 7, function g is on the outside and function f is on the inside. So we will start with function g. Alright, function g is just -3x, so we will do -3 parentheses. Inside goes function f. So that's why we will put 2x minus 1 on the inside. Alright, by now you completely understand that we are going to have to do the distributive property, which is going to give us the final answer in this case, which will be -6x plus 3. Okay, can they stay this easy forever? No, I'm seeing some exponents coming, but we're not afraid. Let's see, this time we have function f on the outside and function g on the inside. So we will start with function f. Okay, so here comes function f. It's 2x minus 1. So you should write 2 parentheses minus 1. Always put parentheses instead of the x. Do not do this and put a little x there. That will be wrong. The x is the parentheses. You know, I keep saying that over and over again, and you probably think I'm crazy because I'm just repeating myself, and you're thinking, yeah, we got it. Don't write the x, put a parentheses. But I've been doing this for years and years, and students will just put the x there and wind up with x squared and 4x and everything else. So I'm trying to save you from yourselves. Distributive property, again, so this is going to be 6x plus 8. And then that minus 1 is still there, don't forget about that. Then we have these like terms, so the final answer should be 6x plus 7. Okay, let's look at example 9. Alright, here's the first one with an exponent in it, so let's watch out for that. Well, for this one we're going to have function g on the outside and then function f on the inside. So let's start with function g. Alright, function g is just x squared. So I'm just going to do parentheses squared. And then inside the parentheses I have to put function f. So that'll be x minus 1. So that's simple enough, but you have to remember how to square a binomial. This is a binomial. The root bi meaning 2. This is one term and the -1 is another term. So this has two terms, it is a binomial. The way you square a binomial, you cannot just square the x and square the -1. That's the common mistake kids will make. But you can't do that. X minus 1 squared really means x minus 1 times x minus 1. And the way we do that is, you know, some teachers call it the FOIL method, and FOIL stands for first, outer, inner, and last. And some teachers just teach it as doing the distributive property more than once. So either way you want to look at it, what I'm going to do, I'm going to look at it like the distributive property. So if I ignore this -1 for a second, okay, if I were to do the distributive property right now, x times x would give me x squared. And then x times -1 would give me -x. That's what I have so far. Okay, now, but I had erased a -1 that was actually there. Now imagine that, forget about the x because I've already dealt with that. But now I'm going to go back and I'm going to also distribute the negative 1. So if I do that, negative 1 times x is negative x. And then negative 1 times negative 1 is positive 1. Okay? That is how you multiply a binomial times a binomial. You distribute the first term, and then you distribute the second term, and then you combine any like terms that you see. Negative x and negative x make negative 2x, because this is like negative 1x and negative 1x. Negative 1 and negative 1 make negative 2. So the final answer will be x squared minus 2x plus 1. Okay, notice if you just squared the two pieces, you would have gotten the x squared and the plus 1, but you would have been missing the negative 2x term. So please don't make that common mistake. Alrighty then. Now for this one, we're going to have function g on the outside, and then we'll have function f on the inside. Okay, now function g is where we will begin. Function g says, okay, x plus 2. So that's just going to be parentheses plus 2. That's function g. Alright, now on the inside I'm supposed to put function f. But function f is just x squared. So I'm going to wind up putting an x squared right there. Well, there's nothing in front of the parentheses. There's nothing to distribute. There aren't even any like terms. So really, all I'm going to do is erase the parentheses, and that is the final answer. So I'm just going to have x squared plus 2. That's it. Okay, just a couple more examples. All right, we're down to the last two examples. Okay, g at f. So we're going to start with function g on the outside, and then we will continue with function f on the inside. All right, first function g. All right, so here's function g. I'll just do it right here, save space. Function g is x squared minus 2. So I'm going to put parentheses squared minus 2. All right, and then inside the parentheses, I'm supposed to do a function f. So that's why inside the parentheses, I'm going to put x plus 3. Alright, now you understand that I'm not just going to square the x and square the 3 and have x squared plus 9. Oh no, we know better now. We have to take the x plus 3 and actually multiply it by itself. So we have to do x plus 3 times x plus 3. Alright, and meanwhile don't forget the minus 2 on the end. But looking at the x plus 3 times x plus 3, if I do my distributive property, if I distribute the x, I'm going to have x squared, all right, x times x, and then x times 3 is 3x. Okay, and then if I turn around and distribute the 3 times x is 3x, 3 times 3 is 9. Okay, and don't forget the minus 2, just bring that down. And then we have these like terms. Actually, so these are like terms, but these are also like terms. So putting those like terms together brings me to the final answer. So this will be x squared plus, now putting these two together makes 6x. 9 and negative 2 make positive 7. Okay, so that should be the final answer for number 11. Alright, finally, number 12. Let's see what we have. So this time we're starting with function f on the outside, and then we'll finish up with function g on the inside. Okay, function f first. It says 6x, so I will do 6 parentheses. Then I'm supposed to put on the inside function g in the parentheses. So that's why I'm going to put x minus 7 in there. All we have to do is the distributive property and we're done. So that's just going to give us 6x minus 42. Okay, so this was a lesson on how to do function composition, or sometimes you will hear it phrased as these are composite functions. But whenever you hear those words, it just means that we are substituting a function into a function, and that is how you do that. I hope this video has been helpful to you. If it has been, a thumbs up, a like is always appreciated. Either way, I will see you on the next video.